Okay, so finishing up 2-2, we have two problems left to go over on the calculator. So I'll make sure you know how to put the stuff in and how to use the buttons. Okay, doing 2-3. You'll get the quiz prep for the closed interval from 2.1 to 2.3. Because that's what the quiz is going to cover. And then next Tuesday, we continue with 2-3 and we get 2-4 and 2-5 because 2-4 and 2-5 are basically related. Solving equation, solving quadratic equation. X squared instead of linear, which is x to the first. This is the majority of the test. This is the big stuff. Then nobody said anything Tuesday, but I left off the 24th. I was sitting up here going, why is it going all the way? No. Oh, yeah, I didn't have the 24th. I missed that day. So next Thursday, we finish up Cap 2 and get the review sheet. That's when we'll take the quiz. It's on the 24th. And it's going to be 2.1 to 2.3. Okay. Review on Tuesday, the 29th. Take the test on the 31st. Homework is due on the 31st. The test is on the 31st. I'm only going to do 3. Which 3 do you want to see? And let me just point out that the last 3 right here would be equivalent of bonus question on the quiz. Number 3. Yeah. 8.324 minus 2.431x equals 10.212 minus 5.101 times 6.3 minus 2.5 x. The directions say give your answer to the nearest hundredth. Right, 1,000. So that's 3 decimal places. So you're going to want to work the whole problem. Round your final answer at the end. Don't round in the middle of the problem. You round at the end, because if you round in the middle, because you don't want to write all those decimals, you're going to end up not being accurate. Simplify both sides completely. On the left-hand side, you can't do anything. They're not like terms. So from left to right, as you work the problem from left to right, you can't do anything here. So bring it down. Rewrite it, 8.324. I mean, this is if you want to get it right. If you're not getting them right, how's your strategy? Is it working? How's your test work? Was it good? Did you actually do the homework and work it out? How's your strategy? You're adults. You are adults.
It's learning.
What's that?
It's learning.
Interrupt my soapbox. Maybe that's a good thing. I ain't been reading, you know, that's okay. Is it good?
Yeah.
All right. But seriously, math ain't gonna change as much as people in charge of the law want to change it. But you know how they're changing it is they're making it tougher for adults to be successful in math because they're not allowing the and they use the word remedial, but I call it foundation.
If you have a strong foundation in mathematics, we can't offer those classes. We can't, not the junior colleges. So what I believe a junior college, community college was supposed to be for is no longer true. To allow somebody to come back to school who's been away from school, or somebody that doesn't want to go away to college right away and get an education cheap before they go spend a bunch of money to finish the bachelor's degree. It's not true anymore, because all they care about is getting you out in 2 years. So if you have to take 2 extra math classes so you have the foundation to pass the math class, like a calculus to get into engineering or whatever, well, you're not going to do that if you're doing algebra 1 or arithmetic, which were my biggest classes 4 years ago, 5 years ago. And those students actually had a lot of success because they were able to go further, because they ended up getting the foundation they never felt comfortable with. Sorry, I wish I could say that my hands are untied, but they're tied. By law, we can't offer it. But what you can do is you have to change how you approach it. Because math ain't gonna change in what you have to learn how to do. One thing you can change is not work the problem out a little bit over here, a little bit over there, not writing it out, not rewriting it from left to right underneath. Minus 2.431 x details. Nothing can be done, so you rewrite the exact same thing. Equal right underneath it. Neatly, not sideways and a little bit over there. Just bring it down right underneath. You can't combine these two as much as you would like to, because you have to multiply before you can subtract. So you have to distribute. So you bring this down, 10.212. And this is going to be a negative times a positive. And I'm going to write this out so you can see what's about to happen. But you can multiply, you can skip this step in a second. It's going to be minus, because it's going to be negative times a positive, 5.101 times that 6.3. And this is going to be a negative times a negative, so this is going to be a positive. 5.101 times that 2.5x. So you don't have to show this step. You can go straight to this one. We have 8.324 still. Minus 2.431 x equal to, this is going to be still 10.212. And then now, use your calculator, minus 5.101 times 6.3. And don't round until the end. 32.1363. Because the directions say round to the nearest thousand, the 6 is in the thousands place. If we're rounding to the nearest thousand, we're going to need to know what's in the 10,000. So we need the whole thing. And then we have plus, you're going to multiply 5.101 times 2.5. And this is 12.7525. 12.7525, and don't forget, that's where your X is. And then don't jump the gun. Step 1 is simplify both sides completely. The left is still simplified. You can't do anything here. 8.324 minus 2.431x
But on the right-hand side, you still have your by terms right. You can actually do that subtraction. 10.212 minus 32.1363. And then again, there's signs. That's a negative 21.9243. And you still have the plus 12.7525 x. Simplify both sides completely. Step one is done. That's just step one. But it makes the rest of the problem easier if you actually complete step one. That's why I put the word completely in there. Simplify completely. So now you make a decision. Step two, separate the variable and the constant. Get your variables on one side, constants on the other, and in that order. Focus on the variable. We're either going to bring the variable over to the left, and if we do that, you subtract 12.7525x from both sides. Or we're going to take the variable to the right. Since this is negative 2.431x, you're going to add 2.431x to both sides. So do we want to go right or left? Right. We go to the right, we add, so we end up with positive x values. Not a bad choice. Think before you move. So we're going to add 2.431. Make sure if you're going to do this by hand, your place value lines up correctly. Otherwise, if you just punch it into the calculator, that's fine. On the left-hand side, all you have is 8.324 equal to, this is still negative 21.9243. On this over here, we have positive. And when I say your place value line up, if I write this like this, 2.431, then this thousands place is lined up underneath the 10,000 place. You can't add 1,000 to a 10,000. This is in the ones place and it's right underneath the tenths place. You're not going to add 7 and 2 because they're in different place size. So you want to make sure the easiest way is to line up the decimal, 2.431. So that way your decimals values, your place values all line up. That's what makes the difference of getting something right or wrong when you don't have a calculator. So over here, right here, what is here if there's nothing there?
There.
0. 5 plus 0 in the 10,000s, we get 0. So actually we get 5. 5, we have that x. 2 plus 1, that's a 3. 5 plus 3, there's an 8. 7 plus 4 is 11, carry the 1. 1 plus 2 plus 2, that's a 5, a decimal, and a 1. 15.1835x. And if you have reservations about it, you just go 12.7525. And you add your 2.431. 15.1835. But remember, it's the x. Bring the variable down. That's what you're solving for. We took the variables to the right, so we got to bring the constant to the left. So we're going to add, because it's a negative. And if you don't bring that negative all the way down with it, you're going to mess this part up. 21.9243. Decimal point lines up 9243. Ten thousandths, we get a 3. 4 plus 4, we get an 8 in the thousands. 2 plus 2, we get a 4 in the hundredths. 3 plus 9, we get a
12 in the tens, we carry the 1. 1 plus 8 plus 1, that's 10. So that's a 0, carry the 1. We get 30.2483 equals 15.1835x.
Yeah, there's a lot to keep track of, but you just take it one step at a time. Simplify both sides completely. Just simplify. Don't worry about solving it. You're just simplifying. I'm still doing step 2, or actually I just finished step 2. Separate the variables from the constant.
So I focused on the variable first. I took the x's over to the right side. So here's all the x's in the equation. Since we took the x's over to the right, now I'm going to take the constant over to the left. To undo the negative 2.431x, we add to both sides. Since that's a negative 21.9243, we add 21.9243. So now step 3, what do we have left? Multiplication, and we undo multiplication by division. We divide both sides by 15.1835. Do not put x down here because you want to have x that you're solving for. So this is what you punch into the calculator. This divided by that. So that is 30.2483. And we're dividing by 15.81835. So we get x equals 1.99218. Two 1.82303. But the direction said round to the nearest thousand, tenths, hundredth, thousand. So does the 1 round to up to a 3 or leave it at 2?
Leave it.
Leave it at 2. So final answer, x is equal to 1.992. This could have just been, you know, eight minus 2x equals 10 minus 5 times 6 minus 2x.
But it's not. It's got a bunch of decimals. You treat this
The same way you treat this. It's just got
decimals. Same question, just decimals.
That was number 3.
So 2 more.
Number 2. And just show of hands, how many of you are planning to stay to do the bonus questions at 12? Just a show of hands. No. This is something that that announcement that I put up last Tuesday. Can you solve something with fraction? Step one, simplify both sides completely. Undo fractions by multiplying every term by the least common denominator. So we gotta figure out the least common denominator because this has fractions in it. We don't want fractions. Avoid it. So we have to undo a 5, a 3, a 12, and a 20. Pick any two denominators and start. Well, what's the first common denominator for a 5 and a 3? What would undo a 5 and a 3 denominator? A 15. So now 15 and 12. What's the first number that would divide a 15 as well as a 12? Because 15 won't undo the 12. That won't work. What? 15. 60. 15, 4 times 15 is 60, and 5 times 12 is 60. So the least common denominator, if you just have a 5, 3, and 12, would be a 60. But there's also a 20 to consider. What's the first number that 20 and 60 can go into? 60. 60. So the one number that undoes all the denominators is 60. If you had to add all those fractions together, common denominator would be a 60. So that's what's going to undo the fractions for us, multiplying each one of these by 60. So you actually should, and you would, and you better write 60 next to each fraction. You multiply every term by 60. Even this one. And then the denominator is reduced. 5 goes into 60 12 times. 12 times 6 is 72. Minus 3 goes into 60 20 times. 20 times 2x, I already brought that up minus. 20 times 2x, that's a 40x. Plus, 12 goes into 65 times. 5 times 19, don't forget the x. 5 times 19 is 95x. Equals 20 goes into 60 3 times. 3 times 3x is 9x. Minus 3 times 60 is 180. No more fractions. Step one, simplify completely, undo fractions. Well, we undid the fractions, but we're not done simplifying. On the left-hand side, we have a couple of like terms. The 2 terms with the x. So bring down to 72. Negative 40x plus 95x. So negative 40 and a 95 is a positive 55x. Equals 9x minus 180. Careful with your signs. So that's step one. Simplify both sides completely. Step two, get your variables on one side, then get your constant on the other. So think about it before you do it. Either bring the x's to the left, so you would subtract 9x from both sides, or take your x's to the right, you subtract 55x from both sides. So where are we going, left or right?
Left.
Let's go to the left. So we're going to subtract 9x from both sides. So from left to right, write down what you still have. You have 72 still. 55x minus 9x is positive 46x. Equals negative 108. And since we brought the x's, the variable, to the left side, we're going to take the constant over to the right. So you have to subtract 72 from both sides. So that's 46x equals Negative 180 minus 72 is negative 252.
So the variable on one side, constant is on the other. We separated the variable and the constant. So now step 3, undo multiplication or division. And by the way, here's a little sidebar hint. If you undid the fractions in step 1, then step 3 would just be undoing multiplication, because you wouldn't have division left over. You wouldn't have anything divided because there'd be no fractions. So really, step 3, if you did step 1 correctly, would be undo multiplication. You're now going to divide. Divide both sides of the equation.
Negative over a positive is going to be a negative. Most important thing I'm going to take care of is that negative. And then you have to simplify, reduce all your terms, all your ends of load. I don't know what's going to go into each one. I'm just going to do, they're both equal. So this is 2 times 126 over 2 times 23.
So now I have 126 over 23. Now, 23 is prime. So if 23 goes into 126, then I would have a final answer. 23 does not go into 126. So since they have no common factors left,
Negative 126 over 23. All right, one more. I know it's kind of small, but I didn't want to erase the right side.
Can you do the one that goes under it too?
No, this one,
No. The one.
this one right here, though, this one. The, what is that?
Yeah.
Five over x minus 5 minus 4 over x minus 6 is equal to 2 over x squared minus 11x plus 30.
we want to undo the fractions in step 1. So the denominator is x minus 5, that denominator is an x minus 6. So I want to multiply the least common denominator. In order to undo an x minus 5, I would have to multiply by an x minus 5 to undo this one. To undo an x minus 6, I would have to multiply by an x minus 6 to undo that denominator. So I would have to multiply by both of them
To undo this denominator, I would also need to multiply by an x squared minus 11x plus a 30. So I'd have to multiply by all three of those things, unless, let's pretend this was a 2, that's a 3, and over here this is a 6.
If it was a 2, 3, and a 6 denominator, what's the least common denominator of a 2, 3, 6? 6. So what would undo the
Fractions, I would need a 2, I would need a 3. Do I also need a 6 and multiply by all three things? Or will just 6 work? Do I got to multiply everything and use 36? Or will just 6 work?
6 would work. I don't need all of them.
So maybe I don't need all three of them. Maybe, just maybe, this is that multiplied together.
And right now, yeah, it is.
If you multiply this out, and this is how it'll be on the quiz, x minus 5 times x minus 6 is x squared minus x times negative 6 is negative 6x. Negative 5 times x is negative 5x. A negative times a negative will be a positive. 5 times 6, 30. X squared, negative 6x minus 5x. So negative 6 and negative 5 is negative 11 times x. And then a plus 30. So these two are going to undo that. I don't need that as well.
Okay. This is just like I did 2.1, number 39 and number 36. And 39 showed you a problem where it came factored. So it was all in front of you. But 36 came like this. And I did 39 before 36 because they wish they would have done it. So watch a minute. So this is just an evil way of hiding the fact that the least common denominator is just x minus 5 times x plus 6. Or x minus 6. That's how the bonus will be on the quiz. Now, the test, who knows? Maybe that's not going to be. Maybe it's going to be x minus 5 over here times x plus 4.
So different. You would have to be able to factor.
So, little heads up. In the co-recs next week, the Monday, Wednesday, the Tuesday, Thursday, co-rec, we're going to do factoring. You're going to have to know how to do factoring. If you can be here, that's probably better than just watching the video. If you can't be here, watch the co-rec videos. I'm not going to cover factoring in here. I'm just going to factor. But in the co-recs, I'm going to do it step by step. Some of you learned factoring in high school. And they did something called bottoms up or some diamond method or crisscross apples. I don't know. All of that is crap. Whoever your teachers were back then, I have a hit squad. We need to take them out because they're lazy. They taught you that because they didn't want to teach you how to think. In order to factor, you just have to undo the puzzle. And if you can think, then you can take on the next thing, the next level. Now, if you choose to use those other methods when you do chapter 2.4 and 2.5, I'm not going to stop you. You just got to show your work. That's all. But I'm going to show you how to think in the co-rec. So you can go on to the next level and you don't have to worry about doing some crappy method. I don't even know how to teach those methods. All I know how to do is think. Because I'm not going to memorize them. And I couldn't memorize them if I wanted to do anymore anyway.
So. So the least common denominator, and as you can see, first thing I'll probably want to do is, now that I know that this is comprised of these two, I'm going to rewrite this as 5 over x minus 5. This is 4 over x minus 6. And this equals, this is 2 over, conveniently, x minus 5 times x minus 6. If all else fails, you know, in life, you just have to be Aretha Franklin. You got to think. If you don't know what that is, then you need to watch Blues Brothers. So the least common denominator, every term is going to get multiplied by x minus 5 times an x minus 6. And yes, you do this, each one. Each one gets multiplied by an x minus 5 times an x minus 6. It's like every time I go on some kind of weird rant, the camera doesn't want to hear that. All right. It's like my family at home. They tune me out of it. I'm supposed to do. They're rude. You tell Dad, throw something, because they want to go fetch it. So now you see how we can undo the denominator. The x minus, oh, wait a second. I forgot. Just in case, let's prepare ourselves for problems that won't have answers. Just in case, this x better not equal 5. Because if x comes out equal to a 5, we got to throw it away, because then you would be divided by 0. This x better not equal a 6. So just in case those two, if they happen, we can't use them. Maybe you get 5 and 6, so you throw the 5 out. Sorry, you get a 5 and a 4. You throw the 5 out, you get to keep the 4, which is 2.4, 2.5. Check. X minus 5 reduces, and we're left with 5 times x minus 6. Minus x minus 6 reduces, we're left with that 4 times the x minus 5. Equals. The x minus 5 reduces, the x minus 6 reduces, all you have left is the 8. No small fractions. You don't like fractions. I hear that all the time. It's in step 1. It's step 1. Simplify. We're still not done simplifying. So we distribute. 5 times x is 5x. 5 times negative 6 is negative 30. Distribute. Negative 4 times x, that's negative 4x. Negative 4 times negative 5, that's positive 20. Equals 2. Need to simplify. Positive 5x minus 4x, so we'll get just x. 5 minus 4 is just 1x, just x. And then negative 30 plus 20, what do we get? Negative 10 equals 2. So x minus 10 equals 2. So get your variables on one side. There's the only variable. Constant goes to the other side, add 10. And we get x equals a 12, and then, well, we're done. Because there's nothing to divide by. The whole goal is to get X by itself, and there it is. And in case you were not here on Tuesday, I want to make sure you understand, this is not the homework. The homework is the assignment sheet. That's the homework. This is what you're supposed to do. This is what you're responsible for. This is what you turn in. This is what you score. This is what I score you out of. These are the examples that I do so you know how to do the homework. So if this happens again, I will just basically nullify any of those that you actually try to get away with. I don't know if you're trying to get away with it, maybe it's a misunderstanding, but shouldn't have been, because it kind of says this is your homework. So now I believe that we should be clear. All right. Finishing 2.2. Number 45 or 47. This is calculated stuff. So you're supposed to punch it up in your calculator and use the options on the calculator to find the solution for the equation. So 45, 2x to the third minus x squared minus 18x plus 9 equals 0. Or 45, x to the fifth equals 3x to the third minus 3. 47. X to the fifth equals 3x to the third minus 3. And then we're going to do 54 because I want to make sure you know how to enter in an absolute value. So 54, I'll put over here on the side. Negative absolute value of x minus 2 equals negative 6. So you go to your equations. Now, you can only type in an equation to the right of y sub 1 or any of these y's. You cannot type in on both sides of the equation. Y sub 1 equals. So the directions say you're supposed to write this as an f of x in function notation. So basically, we want y equals, just like on the equations there. So we want to get everything on one side. Here's what I really recommend. The biggest power in the whole equation is x to the fifth. The biggest power, positive. You're going to want to work with positive x to the fifth instead of negative x to the fifth. Or whatever the biggest power is, you're going to want to keep it positive. If that means moving these two over to the left, then that's what you got to do. I know moving one thing to the right would be nicer, but we're moving these two to the left because I want to keep this positive. So I'm going to subtract 3x to the third from both sides. I'm going to add 3 to both sides. And I have x to the fifth minus 3x to the third plus 3 equals 0. So this is my function. And that's what they mean when they say in the directions. Remember to write the equation in the form of f of x equals 0. So we wrote it as a function, y or f of x equals, and then what we're actually looking for is when does this function equal 0? What we're looking for are the x-intercepts. So we're going to type in y sub 1 is x to the fifth minus 3x to the third plus 3. Fifth power. And that minus 3x to the third. And then plus 3. That's your function. That's your equation. Now I have no idea what the window should be. So all I'm going to do is zoom standard, which is what earlier in the textbook that's what they told us to do. So zoom standard is options. And what I'm looking for are the x-intercepts. When does this function equal 0 is when y is equal to 0. Because you're supposed to let it equal 0. So you let this equal 0. Y is 0 on the x-axis. So we're looking for the x-intercept. Where does that thing touch the x-axis?
Well, let me say, don't guess. Again, you're not supposed to look at it and know. The calculator is going to do the work for you. I'll show you how you use the calculator. First of all, I have no idea what it is. I'm not going to guess. But I do know that if this is negative 10, 10, I don't need that big of a window. Negative 1, negative 2, negative 3. I'm just going to change my window to negative 3. And I'll just make this side 1, 2. I'll make that positive 2. So my x minimum and x maximum, I'm going to change it to negative 3 to positive 3. Okay. Now I'm going to look at my graph. Because all I care about are the x-intercepts. All I care about is where it crosses the x-axis. I'm going to do one more tiny thing. If all I care about is where it crosses the x-axis, I'm going to narrow the y value. 1, 2, 3, 4, 5, 6. So that's a 6. And all I care about is, let's see, 1, 2, 3, 4. So negative 4. I'm going to change the window for the y negative 4 to 6. Now make it. Because all I really want to do is get that picture so I can figure out what these numbers are. And you just kind of need to know how to manipulate what you want to see. Now, here's one tiny thing. I'm not convinced. What we will learn is the fundamental theorem of algebra. X to the fifth could quite possibly have 5 solutions. At the most, 5 solutions. It might cross the x-axis 5 times. It might cross it 3 times. It might cross it only 1 time. It can only cross it an odd number of times. Right now, it looks like it's touching it, crossing it 2 times, which would be wrong. So, you know what I bet? You can't see it. It actually is going down, below, and above. So I'm going to change my window. -1, that's -2. I'm going to change it to -2. And over here to +2. And again, all I care about is the x-axis. And I'm going to change the y value from -1 to 1. So my x min is -2. So I can see that intercept. X max is going to be +2. So I have that in the picture. So between those two, the y min, -1, and the y max, +1. So I can have 0 in the picture. But if I don't have the x-axis in the picture, I won't see where it's crossing. -2. So +2. This 2. -1. 1. Right, one more time. It's not touching it at all. This equation only has one solution. An x to the 5th can have at most 5, or 3, or 1. They can't have an even number. That's something called the Descartes rule of sign, accompanied with the fundamental theorem of algebra, which is further along the solution. The only solution is right here. And this is -2, and that's -1. So we're going to tell the calculator, find me that answer. Now, some people like to just go trace it. And here's the problem with tracing. You hit trace and you start moving the cursor back and forth, and you try to trace it over there, and you know what? You're never going to get perfectly on 0. So why trace when the calculator will actually give you the answer? So you right above the trace button, calc. So you got to hit second and then calc. And you have all these little tools that the calculator will do. Option 2, 0. It will find the solution where the function equals 0. It's going to ask you some questions though. Left bound, right bound. So it's going to ask you, where do you want me to look? Where do you want the calculator to look for the solution? We want to look for the solution in between, left bound, between that -2, and just, you got to go, the other side of this answer. So I'm just going to go look between -2 and -1. So would you please look between -2, there's my left bound, and look between -1 for the right bound. And you can't see it, that little thing right there is a little triangle, little arrow, and it's pointing in both directions like this. We're going to look in between here and here. So the calculator is confirming that they're going to look between the left and the right side of that answer. And then it says, do you want to guess? No, I don't want to guess. Why would I guess? I want you to guess. So you just hit enter. The function equals 0 when x is -1.861478. There are some equations that don't factor, that don't work with quadratic formula, that don't work with a completing square. The only way to solve it is to punch it up. And that's an example of how that. Now 54, absolute value.
So first of all, you got to be able to enter it into the calculator as y equals. So you can't have something on both sides. You got to get one side. So we either take this absolute value of negative absolute value of x minus 2, take it to the right side, or we bring negative 6 over to the left side. Well, we got to have everything on one side. So do we want to bring the 6 over or take the absolute value?
Bring it over.
What?
Bring it over to the other side,
Bring which over?
the -6.
Okay, so we add 6 to both sides. And you can write it as 6 minus the absolute value of x minus 2. But here's what we just got done doing for chapter 1. Negative absolute value x minus 2, and that's a positive 6. Y equals a absolute value of x minus h plus k. Exactly what we just got done doing. What's the a? -1. So that means it's going to be flipped. It's going to be upside down instead of right side up. And it's a V shape. What's the h? Positive 2. So it's going to get shifted to the right 2 times. What's the k? It's 6. So the vertex is supposed to be at 2, 6. So if we were going to graph this by hand, it would go 2 to the right, up 6, and it would be here, 2, 6, and then you would have this. And you would have an x-intercept there and an x-intercept there. If you had to graph it by hand. A, H, and K are not going away. So we're typing in y sub 1 equals negative absolute value of x minus 2 and then a plus 6. Here's how we do this. Fill it out. I need a negative. Down here, there's my negative. The absolute value. You hit math. That math button. And math is under the second column where it says no. We got math, num, cook, and boom. We're going to go to the num column. And the first option is abs, which is absolute value. We hit enter. So negative absolute value, and then we bunch up x minus 2. So that's the negative absolute value of x minus 2, and then plus 6. Now I'm going to set up a window. Now, I did this. I know where this stuff is going to be. So I should probably set up a window. Maybe it goes from, let's just say -5 over here. Well, you know what? I'm just going to do zoom scan. That's where everything usually starts in. Zoom scan. So zoom. That way I'm not guessing. Options. So we're looking for these two zeros. Where does the function equal 0? And if you count, maybe it's exactly 1, 2, 3, that's -4. 1, 2, 3, 4, 5, 6, 7, 8, that's +8. But don't assume. Make the calculator do the work. So we go calc. Let's find the first 0 option 2. Left bound. So that appears to be -4, but you don't punch in -4. You got to tell it where to look in between. So this is -5. This is -3. So we're going to tell it to look in between -5 and -3. So the left bound is -5. And the right bound is -3. Do I want to guess? Nope. But you see those arrows now in between those two. And right there it's at -4. When x is -4, the y value is 0. And then for the other one, just punch it up again, each second, you can count. 0. And this time we're looking in between. It looks like again 1, 2, 3, 4, 5, 6. That's 7. And if that's 7 there, and then that's 9. You could technically go, let's just look between 0 and 10. If you're not sure. On the left, let's do 0. On the right, let's do 10. Look in between those numbers. Okay, set 8. You don't have to be that zeroed in or that close to it. As long as the answer that you're looking for is in between your left and right bound, it'll find the one in between. Okay. But if I told it to look in between 3 and 5, there is no answer between 3 and 5. There is no x-intercept in between. So it's not gonna tell you. You have to tell it where to look. You have to find, in the picture, where's the problem. Don't get value. First thing, story time. This is a completely fabricated story because I was not around when these things came to pass. So let's think for a second. How could this possibly have happened to our species? How do we come up with numbers, counting? So let's just think of cavemen. And whoever's in charge of the tribe's got to go out hunting saber-toothed rabbit. Don't know how many rabbits to bring back because we don't know how to count. So eventually, as we start to get smarter, we take an old skin of a rabbit. And for every person in the tribe, we put it in a little rock. So for the 4 people in the tribe, I put 1 rock in the skin of the rabbit. And as I kill another rabbit, I take the rock out. So when the skin is empty, I know I have the right number of rabbits. Don't have any numbers, don't have any communication of what numbers are, but I have something called a 1-to-1 correspondence. For every rock in that skin, it corresponds to a person in the tribe. This is a good story. That's that first spark of how numbers can represent things. Because you know what? When the tribe starts to get really big, that sack of rocks is going to get really heavy. So maybe there's another way to carry a sack of rocks. Mentally. So instead of a sack of rocks, we start assigning numerical values.
the evolution of counting. And the first set of numbers, every time, can you finish this? Can you fill in the blank? Blank is the mother of invention. There's a word blank is the mother of invention. Why are things invented? What spurs? What? Good. That's exactly right. It's not the right word, but it's exactly the same concept. Necessity. It's an old phrase. Necessity is the mother of invention. We need something. Okay, a different way to do something. I'm tired of dragging this tree up all, put the tree on wheels. There's got to be an easier way. Easier way to carry rocks. So out of necessity, numerical systems become, not so much invented, but become discovered. And these sets of numbers, and that's what we're dealing with new sets of numbers. The first set of numbers that we probably came up with are called the counting numbers. Also known as the natural numbers. And the first natural number is 1, 2, 3, 4, 5, and it goes forever. But think about if you have a parent with a brand new baby. I don't know how old, but they take the fingers and they start with 1. Naturally, they start learning or teaching a child how to count on their fingers or toes. And what number do they naturally start with when they learn how to count? 1. The counting number. So out of necessity, we have a counting number. But out of necessity, what happens when we have all the rabbits and we're eating and then everybody's had something, so there's no more rabbits? Or there's 5 people in the tribe, I have 5 rabbits, I don't count. How many rabbits do I need to still gather? I have 5 rabbits with 5 people. How many do I need? I don't need to get any. There's no number that represents nothing. Out of necessity, 5 minus 5, there is no answer in the counting numbers. 0 does not exist. In so many cultures, 0 didn't exist for a long time, well into the late 900s. There was no numerical value of 0. Think about it. Roman numeral 0. There isn't. Okay. Central America, the Mayans, they had a 0. When we discovered that set of numbers, it's a new set of numbers because there's no answer here. So the answer must exist in a different set. That set is called the whole numbers. You can't spell the word whole without an O. It starts with 0. The whole numbers start with the number 0. So we're moving along. Feeling good. When we start bartering, we start trading. Eventually, we invent money. If we invent money, we start to spend money. We start to spend more than we have. I'd like to go and purchase, 5 rabbits, but I only have enough money for 3, and I pay you next week. So we create debt. I want to buy 5 rabbits, but I only have enough money for 3, so there's no answer to this. The answer to 3 minus 5 doesn't exist. So there must be another set of numbers where the answer to 3 minus 5 does exist. They just never had a need for it. How could you spend more than you have? That doesn't work.
So if it doesn't exist in these two sets, it exists in a different set. That set of numbers is known as the integers, where you have the positive and negative whole numbers. -3, -2, -1, 0, and 1, 2, 3. So from negative infinity to positive infinity, all of those numbers. But we're still missing things. Hey, let's go out and me and my buddy, I got one rabbit, but there's two of us. And there's no number that represents my buddy and I, one rabbit, two of us. How much of the rabbit do we get? We each get two rabbits, but there's only one. There's no answer to that kind of a situation. 2x equals what? Has no solution in all of these sets of numbers. So if the answer isn't in any of these sets, it has to exist in a brand new set of numbers. We don't have a need for it yet until we get this one. What's the answer? How much rabbit do we get of each? One rabbit, two people. We get a half a rabbit. I don't have a half. Until we have the rational numbers. Every time we come across a brand new need, we learn that there's another set of numbers. Now, the key word in rational is ratio. Ratio means fractions. Ratio means fractions. So a rational number actually has a very distinctive definition. Any number that can be written as a fraction. Any number that you can write as a fraction. All the natural numbers can be written as fractions. 4. I can write 4 as a 4 over 1, an 8 over 2, a 16 over 4, 24 over 6. I can write 4 an infinite number of ways as a fraction. I can change 4 into a fraction. Okay. I can write -2. -2 is equal to -8 over +2 or +4. I can write -2 as a +1 divided by a -1/2. I can write it as a fraction. If I can write it as a fraction, it's a rational. So every counting number is also a whole number. All of the whole numbers are integers. All of the integers are rational. One other way to describe the rationals. Rational numbers are numbers whose decimal repeats or terminates. So if you have decimals, they also fit. Repeating decimals, terminating decimals. I'm running out of room here. Repeating decimal. 0.4444 repeating is just 4 over 9. As a fraction, I can change any repeating decimal into a fraction. 0.75, that's a terminating decimal. Since it has a last digit, this is just 75 over 100, which, I should reduce to 3/4, but I can change a terminating decimal into a fraction. Okay. So counting, whole, integers, rational.
if I have numbers that can be written as fractions, maybe I have numbers that can't be written as fractions. So here comes the Greeks.
Specifically Pythagoras. Pythagoras proved the Pythagorean theorem. That's why he got the name down. And this was the problem that he had an answer for and nobody else did. If you have a square that is 1 on each side, what is the length of the diagonal? Well, the problem is
There's no answer for it. The answer for the diagonal does not exist in the set of numbers that we know of. So if it doesn't exist in this set of numbers, it must exist somewhere else.
according to the Pythagorean theorem, 1 square, or let me do this way. The hypotenuse squared, x squared, is equal to the leg squared plus the leg squared, 1 squared plus 1 squared. So x squared is equal to 1 plus 1. So the hypotenuse squared is equal to 2.
Square a number and get exactly 2 has no answer in all of these numbers. So if it doesn't exist here, it has to exist somewhere.
Pythagoras knew the answer was square root 2.
In whatever notation they used in 300 BC Greece.
Can you expand a bit of what number 5 is, what you described in the last thing?
Pythagorean theorem?
Yes. I don't want to pretend like I read that.
Pythagorean theorem, or that answer square 2, is not rational. It doesn't belong in any of these numbers. It's not in any of these sets. So if it's not in these sets, it must have its own set over here by itself. If these are called rational, then it belongs in the irrational set. If the rational numbers are numbers you can express as fractions, the irrational numbers are numbers that you cannot be written as fractions. If rational numbers have decimals that repeat or terminate, then irrational numbers are decimals that do not repeat. Do not terminate. Which means irrational numbers, they never repeat a pattern and they have no last digit. One of the most famous irrational numbers that we have is pi. Pi is an irrational number. 3.14159, and it goes on forever, but there's no last digit, there is no repeating pattern. So you can never write out the entire number of pi. You know, what we do is we just write, when you want the exact value of pi, we just go, hey, pi. What is pi squared? Oh, pi squared. What's 5 pi? We write 5 times pi, 5 pi. And we just use it as pi. We don't want, even though square root 2 is approximately 1.414, it goes on forever, there's no last digit. So when we work with square root 2, we just use square root 2. Because I don't want to deal with all the decimals. It's easier to work with the square root of 2 as a radical. So irrational numbers like
square root 2, square root 3, square root 5, square root 6, square root 7, square root 8, but square root 8 is a little bit different. I'm going to put it in quotations, but we'll talk about it later. Square root 10, square root 11. Do you see that I skipped a couple?
What did I skip?
What's the first one I skipped? Okay, square root 1. But what is the square root of 1? What times itself is 1? 1. So if I simplify the square root of 1, it's a 1, it's rational.
Because you always simplify. You wouldn't leave square root of 1. Square root of 1 is just 1. What else did I skip?
Square root of 4 is exactly 2. So I wouldn't leave square root of 4 as an answer.
Simplify, it's equal to 2, and 2 is rational. What else did I skip?
Square root of 9. The square root of 9 is exactly 3, and 3 is a rational number. So I wouldn't leave a square root of 9.
So when you have the square roots of perfect squares, you always simplify.
You will need to know how to simplify the square root of 8. The square root of 8 is 2 times square root of 2.
It's still irrational, but you're going to simplify it. And that's something that we will talk about. Probably not, well, we're not going to talk about today, but we're headed.
Another irrational, we got pi, we got square roots, cube roots, and fourth roots will come around. But one other one that you're going to see this semester is the irrational number e.
E is a number. We use E as the natural logarithmic number. Okay, when we do power, when we do exponential functions. Okay.
E is approximately 2.7188, and it goes on forever. If you look at your calculator, you see something on you see a button that says natural log, or maybe it even says ln x. And on that button right above it is e to the x. There's an e there.
E is a number.
All of these sets of numbers, out of necessity, this has been your world. All of these belong in one family. And that family is known as the real number. When you make a number line, all of these kinds of numbers are on the number line from negative infinity to infinity. They're all real numbers. Counting numbers, whole numbers, integers, rational and irrational. So like right here, you got your 0, you got your 1, you got your 2. So right in here, you got your 3/2, so there's a rational. You got your -1, and right in here, square root 2. Square root 2 would be right about there because it's 1.414.
So it's a little bit less than 1.5. But it's there.
Out of necessity, everything came around. And then out of necessity, you have the question.
When we come up with another problem, we're faced with another problem. X squared is -1.
And we try to solve this. And we know when we square something, it's the same thing. So it's a positive times a positive. Well, a positive times a positive won't be a negative. And we know if it's a negative times a negative, because it has to be the same thing, a negative times a negative is a positive, not a negative. Well, then somebody in the group says, how about a positive times a negative? Well, if it's a positive and a negative, then it's not the same thing. You're not squaring something. That have to be the same thing. So it's either positive, positive, or negative, negative. Either way, you're not getting a negative. So it's impossible to square one of these real numbers and get a negative. So there's nothing here that solves that. And if there's nothing here that solves that, it must exist in another set. There must be some other set over here where the answer works. And if those are called real, then these are called, like the friends I had growing up, the imaginary ones. So we discovered that there's another set of numbers. Now, what do we invent? We invent notation. The numbers exist already. Where do they exist? In chaos theory, they exist in discrete mathematics. Do you know what wind shear is? Turbulence. These are used to explain those kinds of phenomena. So we take the square root of both sides and we assign the square root of -1 is equal to the imaginary number I. So please get used to when you write the imaginary number I, put a little hook on it so they don't get confused with ones and dot your I. Won't be important. So when we have the square root of a negative, it's imaginary. When you simplify, the square root of positive 25, that's just a 5. Odd 25, that's just 5. But now when you simplify something like the square root of -25, so we realize that that is going to be an imaginary number because there's a negative in it. So the first step, poke out the eye. Focus on the idea that it's a negative. Okay, poke the eye. Now just focus on 25. The square root of 25 is 5. So the square root of -25 is 5i. But don't look at it as a -25. Look at it as a negative. Poke out the eye. Now you focus on the 25. Pieces. Take it apart in pieces. The square root of a -8. I know the answer is going to have an I in it. Then I focus on the 8. Well, 8 is a 4 times a 2. And that's the square root of 4 times the square root of 2. The square root of 4 is 2. And then times square root of 2. That's how I got this. Because 8 can be written as 4 times 2. And 8 has a perfect square factor. And that perfect square comes out. So I get 2 times I and a square root 2 left behind. And we will do more examples of this on Tuesday next week. Okay. So now your whole life has been real numbers. Now you have imaginary numbers. And technically, your whole life has been always including imaginary, because your whole life has actually been complex numbers. This is the set of everything. It's the complex numbers. It has a real part. That's the A. And it has an imaginary part. But you already dealt with real numbers. So you've been dealing with, your 5 has actually been 5 plus 0i. That's what you've been dealing with.
That's what it actually has been. 5 all along has been 5 plus, the imaginary part's been 0. 0 times I.
And -7 all along has been -7 plus 0i. But you're going to start seeing things like 4 minus 5i, 3 halves plus 2/3 times I, square root 6 plus I square root 2, all sorts of things.
Combinations of real numbers and imaginary numbers.
A pure imaginary number like 4i. So it's going to be technically as a complex, it's 0 plus 4i. The real part is 0.
But it's got an imaginary part and a real part.
Because I did not get nearly as far as I wanted to, I am going to put a delay on the quiz prep. So you'll get that on Tuesday, and we'll still take the quiz on Thursday, because we'll go over it on Thursday before the quiz. Before we get out of here, though, I am going to show you number 11. All they want you to do is to write number 11 as a complex number in standard form. Number 11 is 4 plus square root -9. All they want is you to write this as an A plus a BI in standard form, complex number. So, first of all, simplify the radical. So 4 doesn't change. And then it's still plus square root of -9. So poke out the I. That takes care of the negative. Hey, what's the square root of 9? Yeah, you're done.
That's number 11.
Now it is 3 times I, not 4 plus I3. You're going to treat I like a variable. 5i plus 2i, 5 plus 2, that's 7 i's. I squared times I to the third is equal to I to the what? I to the fifth. You add the powers if you're multiplying.
You treat I just like a variable. Now, there's other things that we do with it, but you treat I just like a variable. Adding, subtracting, multiplying, all the rules still apply. Which is nicely convenient. All right. If you are late, make sure you see me. If you're staying for the bonus,